Elon Musk, the architect of failure as a stepping stone to success. Elon Musk's career is one of the most compelling modern narratives, proving that failure is not the opposite of success, but an integral part of its evolutionary process. He has not merely endured setbacks, he has actively cultivated a culture of aggressive risk taking, where catastrophic failure is an expected and even necessary outcome on the path to radical innovation. His two flagship companies, SpaceX and Tesla, offer the most vivid large-scale case studies of this philosophy in action. The crucible of catastrophe SpaceX and the first four launches. The clearest demonstration of Musk's use of failure as a stepping stone is the harrowing origin story of SpaceX. His goal was not incremental improvement on existing aerospace technology, but a revolutionary leap, making humanity a multiplanetary species by drastically reducing the cost of space access. This mission was so audacious that traditional aerospace engineers considered it borderline lunacy. The three failures and near bankruptcy, 2006 to 2008. Musk invested $100 million of his personal fortune from the PayPal sale into SpaceX, believing he had enough capital for three launch attempts of his first rocket, the Falcon 1. The results were financially and psychologically devastating. First launch, March 24, 2006. The rocket failed less than a minute after takeoff due to a fire caused by a faulty component. The lesson, a simple mechanical failure, a leaking nut, brought down the mission. The company learned the acute necessity of meticulous, internal quality control and redundancy, rejecting the traditional aerospace model of over-reliance on external suppliers. Second launch, March 21, 2007. The Falcon 1 made it further this time, but the first stage ran out of propellant earlier than expected. The lesson, this failure was traced back to residual fuel slosh, which damaged a turbopump. The experience forced engineers to better understand the fluid dynamics and control systems of their engine, leading to crucial design modifications in the Merlin engine. Third launch, August 3, 2008. This was the most painful failure. The rocket carried three different customer satellites, and the mission failed due to a residual thrust in the newly separated first stage, which caused a collision with the second stage. The consequence, the total loss of three customer payloads led to widespread public ridicule, and more critically, it eroded the company's financial reserves to the point of collapse. SpaceX was out of money and had one final rocket structure left. The triumph of the fourth attempt. Musk was under unimaginable pressure. Tesla was also nearly bankrupt, and the end of 2008 marked the nadir of his professional life. He took the last $30 million he had and split it between the two companies for one last desperate attempt. The success, September 28, 2008. Against all odds, the fourth launch of the Falcon 1 successfully reached orbit, carrying a dummy payload. The stepping stone, the success proved the entire concept. A privately funded, developed, and launched vehicle could reach orbit. This single triumph, born from three public catastrophic failures, immediately secured a crucial $1.6 billion contract from NASA for the Commercial Resupply Services (CRS) program. The very act of almost failing led to the credibility and funding needed to survive and eventually thrive. SpaceX's current dominance in reusable rocketry, Falcon 9, Falcon Heavy, and the ambitious Starship program continues this cycle, with spectacular test explosions being treated not as mistakes, but as the fastest, most effective way to gather engineering data and advance the design. A clear embodiment of the philosophy that failure is a design requirement for innovation. Production hell and the power of first principles. Tesla. While SpaceX faced physics and engineering failures, Tesla's major crisis was one of scale, manufacturing, and operational execution, a period Musk dubbed production hell during the ramp-up of the mass-market Model 3. The flawed vision of the alien dreadnought. The setback, Musk's initial vision for the Model 3 factory was the alien dreadnought, a fully automated, robot-only production line with minimal human intervention. He believed the ultimate product would be the machine that builds the machine. The reality was a disaster. The highly complex robots, purchased and designed at immense cost, failed to meet targets, struggling with simple tasks and compounding errors, slowing production to a crawl. The company was hemorrhaging money and missing critical delivery goals. The failure analysis, Musk publicly admitted the mistake, stating, "Yes, excessive automation at Tesla was a mistake. To be precise, my mistake. Humans are underrated." This admission of failure was the key to the solution. The course correction and success. Musk's famous course correction was a physical embodiment of his pragmatic response to failure. 1. Reintroducing humanity. Tesla dramatically reduced automation in key areas, putting human workers back on the line where flexibility and common sense were needed. 2. The tent assembly line. To quickly fix the bottleneck and hit the goal of 5,000 cars per week, Musk had his team construct a temporary, semi open assembly line known as GA4 in a massive tent outside the main Fremont factory. It was a crude, low tech solution to a high tech problem. 3. The stepping stone, the temporary tent line worked. It proved that a simpler human assisted process could achieve the necessary throughput. By confronting the failure of over automation with pragmatic, on the ground engineering, Tesla survived the crisis and proved it could mass produce a viable EV, leading to its eventual status as the most valuable car company in the world. The lessons learned in that desperate near bankrupt period were baked into the design of future more successful gigafactories. 3. The core philosophy, being less wrong. Musk's experience illustrates a philosophy that is fundamentally different from a traditional corporate approach, which seeks to avoid failure at all costs. 1. First principles thinking. Musk proves that failure is a stepping stone by employing first principles thinking. Instead of looking at past failures as a reason to quit, he asks, what is the absolute most fundamental knowledge gained from this explosion, bottleneck? What are the irreducible components of the system that must be changed? For example, after the first 3 Falcon 1 failures, his conclusion wasn't, rockets are too hard, but we now know exactly where the pressure sensor failed, where the residual thrust caused the collision, and where the fuel slosh occurred. We are less wrong than we were before. 2. The acceptance of extreme risk. The failures he experienced were not minor, they were near death experiences for his companies and for his own financial well being. By repeatedly placing himself in a position of existential risk, he signaled an unwavering commitment to the mission, sustainable energy, and multi-planetary life. This acceptance of high-stakes failure instilled a culture in his companies that rewarded rapid iteration over cautious, slow progress. The maxim, if things are not failing, you are not innovating enough, is not a motivational poster. It is a clear operational directive. Conclusion: the unstoppable momentum of iterative failure. Elon Musk's life and work are a testament to the belief that the true failure is not an explosion or a production crisis, but the failure to try again after a setback. He demonstrated that by 1. Defining the mission. His goals, mass sustainable transport, are so ambitious that they demand technological and organizational failure along the way. 2. Analyzing the failure, treating every setback as an extremely expensive but highly valuable piece of engineering data. 3. Iterating immediately, using that data to launch the next, slightly less wrong prototype or production line. His story is the ultimate proof that perseverance, when fueled by relentless learning from failure, is the only true pathway to disruptive success. The debris of his early rockets and the sleepless nights on the factory floor are, in retrospect, the very foundations upon which his revolutionary achievements were built.